Day 626 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1292, maximum side length of a square with sum less than or equal to threshold. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe. Excuse me, y'all. Don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an n by n matrix that and an integer threshold, return the maximum side length of a square with the sum less than or equal to threshold, or return 0 if there is no such space. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So our input mat, or for the matrix, is a 2D array of integers, first array being, or the top row being 1, 1, 3, 2, 4, 3, 2. Next array, or the middle row, being 1, 1, 3, 2, 4, 3, 2. And the last array, or the bottom row, is 1, 1, 3, 2, 4, 3, 2. The threshold is 4. Output is 2. Explanation says the maximum side length of a square with the sum less than 4 is 2 as shown. So when we're looking right here at this handy dandy visual representation that they have given us, we can see that they have created or outlined two squares for us, one right here in yellow and one right here in red, right? And each one of these squares has a sum of 4, right? Because there's 1, 2, 3, 4. There are 4 ones in each square. There's 4 ones at this red square, and there's 4 ones in this yellow square, which means it has a sum of 4, which is equal to our threshold, right? If we would have put a square around any other element, or if we would have found any other square in this matrix, the sum would have to be less than or equal to the threshold. So we could put a square around this 1, 4, but that would only have a side length of 1, and we want to return the maximum side length, right? So this right now is the maximum side length that we have been able to create that has a sum that is less than our threshold, right? This has a side length of 2, right? Whereas if we did just put a square around each one of these 4s, each one of these 4s would only have a threshold of 1, right? And since we want the maximum, we're going to return this one because this has a side length of 2, and thus the output is 2. Boom. So just in case that didn't make sense, let's take a look at example 2. So in example 2, our input matrix is a 2D array of integers, first array or top row being 2, 2, 2, 2, 2. And as you can see, that's the same for every row. Each one of these arrays represents a different row in the grid, and as you can see, the whole grid is filled with nothing but 2s. So if the whole grid is filled with nothing but 2s, but our threshold is 1, it's impossible for us to create a square that has a sum less than our threshold, because the smallest sum we can create would be 2, right? And that's already greater than our threshold. So since we cannot do that, we are just going to return the 0, because it says right here, return 0 if there's no such square. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Now, the first thing we want to do is we want to get the number of rows and columns in the matrix. So we could just say let R equal mat dot count. Boom. Then we could say let C equal mat square bracket 0, come outside of that, dot count. Boom. Now we need a 2D prefix sum array, so we are going to come right here, create a variable called PS, and set that equal to an array. Open up the parentheses. It's going to be a 2D array, so it's going to be repeating another array. We're going to open up those parentheses. Then we're going to say repeating :0, comma, count, :C plus 1. Come outside of that, we'll say comma, count, :R plus 1. Boom. Then we need to build the prefix sum matrix. So we're going to come underneath this. So y'all, and we're going to say for I and 0 dot dot less than R. Sorry, y'all. I don't know why my computer is going so slow right now. So give it time to catch up or do something. 0 dot dot less than R. Boom. Open up the brackets. Then we're going to declare a variable called row sum, and we're going to set that equal to 0. Boom. Then we're going to say for j in 0 dot dot less than C, we're going to open up the brackets, and we're going to accumulate the row sum by saying row sum plus equals mat square bracket I square bracket j. Boom. And then we're going to combine the row-wise and column-wise prefix sums by coming underneath this, and we're going to say PS square bracket I plus 1, come outside of that, square bracket J plus 1, come outside of that. We're going to set that equal to PS square bracket I, come outside of that, square bracket J plus 1, come outside of that, and we're going to say plus row sum. Boom. Now we need a helper function to check if there exists a square submatrix of size and length whose sum is less than or equal to the threshold. So we're going to come right here outside of this for loop, and we're going to say declare func, call it OK, open up the parentheses, we'll say underscore len colon, that's going to be an integer, and we are going to return a boolean. Boom. Just like that. Open up the brackets. Now, square of side length 0 is always valid, so we can say if len equals 0, then we can open up the brackets and we can return true. Boom. Now we need to iterate over all possible bottom right corners of squares with the side length. So come underneath this and we'll say for I and len dot 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 R. We'll open up the brackets and we'll say for j in len dot 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 C. Then we'll open up the brackets. And we're going to compute the sum of the square submatrix using prefix sums. So we'll say let sum equal PS square bracket I, come outside of that, square bracket J. Now I'm going to come underneath this just to make it look clean, but then we're going to say minus PS square bracket I minus len, come outside of that, square bracket J. Once again, I'm going to come underneath this and say minus PS square bracket I, come outside of that, square bracket J minus len. And then once again, come underneath that. And this time we're going to say plus PS, oh sorry, equal white space, y'all, equal white space, boom, plus PS square bracket I minus, sorry y'all, square bracket I minus len, come outside of that, and we're going to say square bracket J minus len, boom. Now we're not done yet, because if any square satisfies the threshold, we need to return true. So we can come underneath this and we can say if sum plus equals threshold, then we can open up the brackets and we can return true. Boom. Now, if no valid square is found, we could just come right here at the bottom of the helper function and we can return false. Boom. Almost there. Still got a little bit more to go though, y'all. So now we need to complete our binary search over the possible side lengths. So we're going to declare a variable called low, set that equal to 0, declare a variable called high, set that equal to the minimum of R comma C. Boom. Then we're going to come underneath this and we're going to say while low is less than high. We're going to open up the brackets, and we are going to find the mid by saying let mid equal, open up the parentheses, low plus high plus 1. Then we're going to come right here outside of this, and we're going to say greater than 1. Boom. come underneath that, and we're going to see if a square of size mid is valid, then we'll try bigger. So we'll say if okay, open up the parentheses past it mid, then we'll open up the brackets, and we'll say low equals mid. Else, we're going to come right here on this if statement. We're going to say else, we'll open up the brackets. We'll say high equals mid plus 1. Or excuse me, mid minus 1, y'all. Mid minus 1. Boom. And now the largest valid square side length, to get that, we could come right here. And all we have to do is say return low, y'all. Oh, sorry, y'all. And this should be low without the W. Make sure spelling's right. So should this. Boom, y'all. So let's give this a run. Make sure it runs properly before we submit it. And we got our first error. Let's see. Cannot convert. Sorry, y'all. This should not be plus equals. This should be less than. If sum is less than or equal to threshold. So now let's run it. See if that did the trick. Can I find low? Where is that? Oh, yeah. Let's get rid of this W. Run it again. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 7 milliseconds beats dash percent of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.